Hi, I'm Becky Stern, and today we're learning how to make your first printed circuit board. There's a lot of information out there on this topic, and my intention with this video is to introduce the absolute beginner to PCB design and manufacturing. It's never been easier to bring your electronics project from a breadboard to a custom printed circuit board. This is part of my series here on the DigiKey channel, which has over 20 episodes now, filled with answers to all the questions beginners ask. So if you're totally new to electronics, watch the first few episodes to get the background info you'll need to understand this intermediate level topic. Printed circuit boards, or PCBs, are in almost every electronic product you can find today. The colorful little boards host tiny cities of components and conductive traces connecting them, like roads for the electrons to follow. They're made up of layers. Rigid boards are made of fiberglass and have a copper layer on one or both sides. More advanced boards have even more layers of copper in the middle of the sandwich. Flexible PCBs are made of polyimide and can be considerably thinner than even the thinnest fiberglass board. This big plane of conductive metal is then shaped into the circuit design of choice through a photochemical process that removes the material everywhere the circuit isn't. The material applied is called a resist layer because it resists the etchant from getting to the copper below. Then a few more layers are applied on top. One is the solder mask, which covers up all the traces but leaves the solder pads exposed. Then on top of that is the silkscreen layer, which is for graphics and labeling things. Yes, like the same silkscreen used for t-shirts. This is the way commercial circuit boards are manufactured. It's a specialized process that isn't easily spun up or shut down. So that's why you send your designs to a board house instead of doing it yourself. They're making circuit boards all day, every day, and require large batches of boards to process at once. For a more technical introduction to PCBs, check out this episode of the Another Teaching Moment series here on the DigiKey channel. It's where these cool diagrams are from, and it goes into more detail about things like plated through holes. Besides going to the board house directly, there are a few options for getting your small batch of boards made, one of which is DigiKey's DK Red service. Your order for a small number of boards is combined with other customers on a large panel, which is then sent to the board house to get the best cost efficiency. Sure, you can certainly make boards yourself at home. I've tried the old toner transfer and Sharpie resist methods before, where you etch copper-clad boards with ferric chloride or ammonium persulfate. It's fun and interesting, but messy and dangerous. Those chemicals are hard to dispose of, and a little imprecise. And at the end, you don't get a solder mask or a silkscreen layer either. Folks also make prototypes with small milling machines to remove the unwanted copper. But if your circuit has really small components, or you want to make multiples or even a retail product, you'll need to go the professional board manufacturing route. So what do you need to make to hand over to the board fab? A digital design file that specifies what should be on each layer and the shape of the board. So you'll need to pick an ECAD software package. That stands for Electronics Computer Aided Design. KiCad is one popular free option, and you can find a detailed series about using it right here on the DigiKey channel, hosted by Sean Hemel. I'm personally more familiar with using Autodesk Fusion Electronics, formerly known as Eagle. The free version has all of the features needed to create a typical beginner's two-layer board. The leading professional PCB design software is Altium. And you'll find that there are a lot of free tools popping up here and there for PCB design, but they all help you through the same basic steps to design your board. PCB design files all have a schematic and a board layout. The schematic is the circuit diagram, representing the components and their electrical connections to one another in the abstract. The board layout is the physical plan for where the components' footprints are arranged and the individual traces between them. Here's one of my own circuit board designs. It's a replacement PCB for a PlayStation 4 controller. Here's the schematic view on the left and the board layout on the right. I made a whole video about making this board, so I'll put a link in the card above and the description below. Your ECAD tool will provide you with the ability to specify your circuit board connections in a schematic drawing and then define how they will appear as physical traces on your board. The process of creating the traces and making them all fit together is called routing. We're just scratching the surface here, but I want to paint a picture of the whole process. A PCB alone doesn't do anything. It needs components, which need to be attached somehow. For your first PCB, you might solder your components on yourself. If you plan to go this route, make sure your parts aren't too small. Surface mount parts on the smaller end can be a pain to solder by hand. One method hobbyists use for tiny parts is a hot air station to evenly heat all of the pads at once. This can be useful because melted solder only likes to flow to other places of metal that are also hot. Another method to heat everything at once is to use a hot plate to heat the entire board, which is closer to what happens in commercial manufacturing. The next step in the commercial process is to apply solder to the pads of the board, which involves squeezing solder paste through a stencil that's made to match the board. Then a pick-and-place machine dispenses the components and sets them down in their proper locations. Then the whole panel goes through a solder reflow oven, which precisely ramps up the temperature to melt the solder paste, then cools it back down. The solder reflow oven always reminds me of one of those professional bagel or sandwich toasters. So nowadays, you can also easily find a full-service manufacturer who will populate your boards for you. That's called PCB assembly. To do that, you need to send them a BOM, or bill of materials, of agreed-upon components that fit the specifications of your design. If you plan to go this route, you might want to research the available parts from your manufacturer to inform your design, so you don't have to swap anything out later. In general, when sending work to a factory, it's very important to do your homework up front. Most of the time, the people making your stuff have no idea what your design is going to do or what's important about it to you, and they often don't even speak the same language as you. So it's very important to make it as easy as possible to understand your intention by making sure your files are complete and standardized. One more thing I want to talk about is making your own versions of other people's designs. The open source hardware community believes in sharing their board files, so you can find a lot of fantastic free files for all kinds of boards. You can also make use of the vast library of designs available in the DigiKey reference library. For example, I wanted to make my own version of the open source LilyPad coin cell battery holder, so I downloaded the design files, made my own changes, and sent it off for manufacturing. I made a video about that one too. You can check it out on my channel. I hope you're inspired to try creating your first printed circuit board, or at least come away with a better understanding of the electronic products we use every day. I've put links to some resources in the description, including the videos I mentioned earlier, like the episode of Another Teaching Moment about PCBs and Sean's KiCad series. Leave your advice about making your first PCB in the comments so we can all learn together. Check out the playlist with the rest of this series and subscribe so you don't miss the next one.